Hello, my name is James Turner from KDAB. Today I want to talk to you in the final part of our series on 3D topics in Qt 6 about 3D tooling and workflows, which is an extremely important but often overlooked area of approaching 3D topics in any software application. We start by talking about content creation tools, which isn't a thing that as developers we're necessarily very familiar with. These are extremely complex bits of software used by typically designers, possibly even third-party providers we're working with. But to work with 3D efficiently, we need to efficiently use and understand what a content creation tool does and what it doesn't do, and how the skilled users of those tools expect to work day to day. What can you do in a content creation tool? Well, the one we tend to think of is creating 3D assets, starting with nothing and making a model of a tree or a car or a toaster or a table in a kitchen. But that isn't really the only thing they do. That's just one small aspect of creating new objects or meshes from scratch. Typically, they're also used to author complete 3D scenes, to define animations, to create material, set up lighting environments, and usually define arbitrary parameters. And this is a whole complex area which, as a 3D developer, you really need to be at least somewhat familiar with. I'm going to give you a walk around of one of the content creation tools our 3D designers and creators inside KDAB use day to day to create content for us as part of our work on 3D-based projects. What we're seeing here is the Blender tool, which is an open source 3D content creation tool, which has been developed for a very long period of time. So typically you can create meshes, as already been done here, examine them, move them around, set translations. Importantly, as well as the 3D view of the scene, there's usually a hierarchical view of the scene, which we're seeing on the top right here, where objects range in a hierarchy with parent-child relationships, with grouping, and possibly with inherited behavior. So when a parent object moves or is animated, its children will be updated automatically. This logical structure of the scene is one of the most fundamental building blocks that we expect to work with the content creation tool when we have more than a single object, when we have rich and complex scenes. Typically, each object has a series of properties, maybe its position, rotation, and very importantly, its material. It might have names or IDs and other behaviors attached to it when certain things happen. And these can all be edited interactively. The designers and artists working with these tools become very fluid in using this obviously very large and complex UI to efficiently create and update assets and work with it day in, day out, the same way we would use an IDE or other programming tools. Importantly, all these tools allow application-specific data to be added in, custom attributes, custom behaviors, and custom rules. And this can be done very powerfully to enable the content creation author, the artist, to really bring the scene to life and to add in information which is really vital to a particular application, rather than to go and be done separately in a separate tool. So they can really be a complete all-in-one 3D workbench. Once all this rich content has been created, which includes all these different kinds of data, we need to somehow get it into our 3D engine, our 3D library. And that's where export formats become important. Just as similar to Photoshop, where you wouldn't export or pass around a PSD into a web browser, you typically have a rich editing format, which is suitable for very rich, undo, redo, history, and so forth. And then a much simpler format, which is efficient to pass around over a disk's format or over a web connection, can be easily loaded. So in 2D, we are familiar with PNGs and JPEGs. In 3D, the situation is more complex because the kinds of information are more complex and evolve much more. But we have this splitting between source formats, which are used by the tools natively, and export formats, which are usually somehow optimized binary formats. In the old days, each 3D engine would typically have its own custom loading format. You'd go and write and export a plugin for your 3D tool to load files into your engine. And in this step, typically some quite intensive work can be done. Textures can be prepared, resized, meshes can be optimized or reduced in complexity to suit the target. And depending on your workflow, if you imagine targeting different kinds of device, you might have a single source asset, produce many kinds of different output assets, with higher quality, lower quality, maybe different direction of normals for OpenGL versus DirectX models and so forth. In very large 3D projects like a game, this asset export step can take hours and run overnight because there's so much work to be done to what's called condition all the assets for use in the engine. In the past few years, we've been lucky that besides all the engine-specific formats, we do now have a relatively good export format, which is optimized but also supported by the Kronos group, and that's called glTF, which is the GL transfer format. It's an open standard, and it has good efficiency. It mixes text-based encoding for high-level data with binary encoding for mesh and geometric data, and crucially, the data is laid out so it can be mapped directly into vertex buffers and other buffers used in 3D applications. So there's no additional processing required. You can more or less mmap and go, which is one of the very common goals of all these formats, to be able to directly pass mmap locations into your buffer loader. glTF defines standard material system, which includes modern PBR style materials as well as more traditional ones, and this again is extensible and supports standard visual appearances we'd find in a modern 3D engine. It's also extensible, so features such as image-based lighting and different animation formats, scale animations, can all be included in a glTF file in an extensible way. So let's talk about the workflow we'd ideally like to have from our artists and our content creation tools into our program and our 3D engine. What we really want is for designers to iterate on their models and scene and animations as efficiently as possible, because that's what they really want to do and that's what will make them the happiest. This means they definitely want a live preview which shows them exactly the per pixel output they're going to get in our engine inside their 3D tool. Typically this is done by actually running the engine as a kind of visualizer plugin of the 3D tool, so that even if there's a similar material or texture being applied, that actually the same code is run on the designer's computer so they can get a live preview. Once they're happy with something looks, they want to commit their assets to some kind of asset management system. This might look a bit like source control, but there are specialized asset management systems. And they then want to be able to deploy those assets onto the target device, target system, whatever it is, and test them in the software. And ideally, there will be zero development involvement in this, because neither the artist nor the developer benefits from being involved in any of the steps I've just mentioned. It's just an annoyance and trouble for people. And if you've worked on 3D projects, you've probably been aware of having to do manual steps or developer-based steps in order to get content on the screen from a content creation tool. It's very frustrating. We really don't want to do it if we can help it. Unfortunately, this idealized workflow, like all ideals, tends to fall down. We have things that the artist can't provide, especially often in Qt applications. We have real-time data from sensors, so temperature values or radar data or downloading data from online sources. All of these things can't be created in an offline tool because they're not known until the application runs. We also have user inputs, clicking, touching, hardware button events that might trigger a change of animations. We need to have some kind of input into our 3D scene and our 3D behaviors from our C++ or our QML world so we can control it. We might also have dynamic textures from video or camera data, and we might want to modify the scene state based on system settings or other logic in our program to say, okay, hide this bit or switch to this scene or add 10 copies or 6 copies of this object in a line. So all these kind of dynamic changes which the content creation tool and the artist can't predict, and we need to somehow structure and manage while using their work in an efficient way. So the central problem we end up with is called asset coupling. We need some way for the developer and the artist to talk about things so they can reuse them. This ends up being some kind of shared label identifier scheme where particular assets have a unique ID or a name or a file path, and in one direction need to be standardized, looked up. Typically this means, for example, if you think about a toaster, there might be standard parts for the button of the toaster, for the switches on the side, for the bread that pops up. So programmatically we can maybe add and remove pieces of bread or simulate the button being pressed. So we need to have some standard IDs we can find in this complete scene of a toaster to go and drive those behaviors. This is a very common point of failure because people may not realize a particular name or ID is actually important or used. They rename something or reparent it or put in a different file because it makes their life easier. And now when they redeploy the asset, it no longer works in the 3D engine because the correct name isn't found. What we really want to do especially is avoid encoding very particular details of the scene that we then have to reference. So relying on a particular object being a child of another one or particular order of transformations, all these kind of things are very easily done, but introduce very, very fragile scenes where the slightest change, which can happen very easily, that an artist may not even realize significant, can cause something to completely stop working when it's deployed to the 3D engine. Let's look at how these issues are tackled in Qt Quick 3D in Qt 6. So the solution in Qt Quick 3D is to have an intermediate tool which manages the export from the content creation formats something that's easy to work with in our QML world. This is an asset compilation tool which is called Bulsum. It's run as a command line tool, and it more or less is a file processor that takes in your scene and some command line options, and then what it produces is a collection of binary data and then a QML file describing your scene. So essentially the scene's been translated from its normally tree structure with attributes in the content creation tool into actually very similar, a tree structure with items and elements and objects that have properties in the QML world. And the IDs and names of this objects in QML reference or are related to the ones in your content creation tool, so you can then go and use this QML file in a loader, find objects, and do all your normal QML operations on that data exactly as you would. This is quite similar to the workflow in the 2D world with the designer tool, where again, your UI produces a QML file which you don't edit, but rather include and reference and do programmatic operations on. The Bulsum tool can do lots of other content conditioning steps. So it can optimize geometry, making it more efficient, splitting it, merging it, setting the detail. It can fix a range of problems to do with, degenerate data, flipping normals, collapsing bad faces. And it can also do other computational steps. So, for example, it can compute image-based lighting cube maps, which typically has to be done right before the scene is being exported, so you actually know where everything is and can go and render those cube maps ready for use. So again, this is a tool that's designed to be run from the command line with some options, probably from a script or from a CI, Jenkins pipeline, to just be run automatically and produce the right files ready to be included in a resource file or however they're deployed for the application. That brings us to asset loading in Qt3D, where we take a slightly different approach. In Qt3D, we have the scene loader element, which can load various file formats supported by the asset importer library, but crucially, we also have native support for glTF, the GL transfer format from Kronos. Because this is an extensible format and it's designed to be used for runtime loading, we can use it directly. So a glTF file can be opened, the named entities can be found, and we use a special loader called a scene loader. Using this, you can then go and look up those elements and do normal operations, hiding them, showing them, connecting the signals on them, setting attributes, and so forth. This is a very powerful way. You can simply save glTF in your content creation tool and immediately load it in Qt3D and work with it and do dynamic operations with it. Part of the reason we picked to use glTF this way is because glTF is an extensible format and an open format, which of course fits nicely with some of the philosophy around Qt. Especially this means that we have the option to greatly extend the basic features of glTF with custom entity properties we might use for particular things in Qt3D. At the same time, letting designers keep working their existing tool, because at this point, all the major tools have pretty good glTF support. So we don't have to go and force people to use a particular tool that we have a plugin for. Anyone who can produce glTF can produce content that can be loaded directly in Qt3D with no compromises, no data loss in translation. And in principle, this means we have the happiest outcome, where we have happy developers and happy designers and no conflict over who's doing what or things getting corrupted or mangled. Now, just to give you a small plug, this is such a good idea, we've developed based around it called Quasar, which is designed to exactly include some customizations and enhancements to really give a seamless workflow for content creation from these kind of tools we're talking about into Qt3D and render it with full support for lighting, animations, materials, effects. If you want to learn more about Quasar, go look at quasar.com. Of course, that's only an additional set of features, convenience, and tooling around the basic support, which is for glTF in Qt3D. So to wrap up some conclusions around this, the really key one is that content workflows have a big impact on developers, but also on non-developers. They're a thing where a small choice can have consequences for even hiring people and budgets and timelines. Especially if you have an inefficient workflow around this, you can waste hours and days of very unproductive time recompiling, waiting, compressing, uncompressing, rebuilding assets, all of which is extremely expensive and tedious work with nothing really to show for it because you didn't plan a good workflow at the beginning of your development cycle. Even worse than that, to have a content pipeline up and running, the inertia on changing it is usually very high. In the worst case, you might have to go and recreate all your existing assets, which could be just unfeasibly expensive. If you have a few hundred assets created already, the idea of having to go back and recreate them or substantially rework them if you want to move to a different content pipeline might simply be unacceptable. Of course, the pipeline you're using is inefficient, there's a trade-off there if you want to waste more time with sticking with your inefficient pipeline or reworking assets. This is a bit like, technical debt in a code base. So it's really important upfront to get a good workflow established. This is where some of the commercial 3D engines have really done a really good job ensuring the workflow is always seamless and predictable. Of course, they have other trade-offs we've already talked about in previous videos in this series about their feature set. But it is important, whatever solution you end up using, that your content workflow is really smooth for everyone involved, not just developers. That brings us to the end of this video series on 3D topics in Qt 6. To find out more about anything we've talked about, of course, look at our other videos on our YouTube channel or visit kdab.com to see what we're up to with 3D topics in Qt and beyond as time goes on.